If you cut open a piece of Roman concrete, it doesn't look like the smooth gray sidewalk outside your house. This is terrifying for a builder. It's dangerous. This completely changes how we view engineering. Why would anyone build a wall filled with tiny ticking time bombs of unmixed chemical? The Romans optimized for resilience. They understood that the world is chaotic. The ground will shake, the rain will fall, cracks will happen. Instead of trying to build a wall that never cracks, they built a wall that knows what to do when it cracks. If you know this Roman secret, you can build a house that can last for thousands of years. I want you to picture two structures. Structure A is the Pantheon in Rome. It was built nearly 2,000 years ago. It has the largest unreinforced concrete dome in the world. It has survived earthquakes, wars, and the fall of an empire. Today, it is pristine. Structure B is a highway bridge built in New Jersey in 1970. It is barely 50 years old. It is reinforced with modern steel. It was designed by computers. And yet, it is already rotting from the inside out. We live in the age of advanced materials science. We can build carbon nanotubes and silicon chips. Yet, for some reason, we seem to have forgotten how to mix rock and water. For decades, engineers have looked at Roman concrete with a mix of jealousy and confusion. We assumed that the Romans possessed a lost secret. Maybe it was the specific volcanic ash they used. Maybe it was the seawater. Maybe it was just magic. But recently, a team of scientists at MIT decided to stop looking at what the Romans got right and started looking at what they got wrong. They found a defect inside the concrete, a flaw that is in every single sample of Roman walls. For 100 years, modern engineers looked at this flaw and said, wow, the Romans were actually kind of sloppy. But they were wrong. That sloppiness is the machine. And the reason our bridges are falling down is that we were too arrogant to realize that perfection is a trap.
To understand the mystery, we have to look at the recipe. For the longest time, we thought we had solved this. We looked at ancient texts from Pliny the Elder. He practically gave us the shopping list. He wrote that the best concrete is made from Pulvis puteolanus, volcanic ash from the Bay of Naples. So, modern engineers said, aha, it's the ash. We analyzed it, we found it creates a rare mineral structure called aluminum tobermorite. It acts like a glue that gets stronger over time. Case closed, right? We just need to use volcanic ash. So we tried that. We mixed modern concrete with volcanic ash, and guess what? It was better, but it still wasn't Roman quality. It didn't last 2,000 years. There was something missing, a variable we weren't seeing. This brings us to the defect.
If you cut open a piece of Roman concrete, it doesn't look like the smooth gray sidewalk outside your house. It looks messy. Specifically, it is filled with these tiny, millimeter-sized white chunks. Geologists call them lime clasts. For generations, the consensus was that these were mistakes. Here is the logic. To make concrete, you mix cement with rock and water. If you don't mix it well enough, you get clumps of unmixed cement. In modern engineering, a clump is a weak point. It's a bubble. If you pour a foundation and your boss sees white clumps in the mix, you get fired. It means you didn't grind the materials fine enough. You were lazy. So when we looked at the Pantheon, we applied our own standards. We said the Romans were brilliant architects, but they were mixing this stuff by hand with hose. They obviously just did a bad job of mixing. We viewed these white chunks as the survivorship bias of the material, impurities that the concrete survived despite having. But the MIT team asked a dangerous question. What if the Romans didn't make a mistake? What if they put the chunks there on purpose?
This leads us to the chemistry of the hot mix. In the modern world, when we use lime for concrete, we use slaked lime. That means we take the rock, mix it with water before we put it in the concrete and let it react. It's a safe, chemically stable paste.
But the evidence suggests the Romans used quicklime. This is the raw, dangerous, unstable form of the rock. And they didn't mix it with water first. They threw it directly into the wet concrete mix. When quicklime hits wet concrete, it triggers an exothermic reaction. It gets incredibly hot, up to 200 degrees Celsius, 400 degrees Fahrenheit. This is terrifying for a builder. It's dangerous. But this high heat does two things. It speeds up the curing process, great for building an empire quickly. It prevents the lime from fully dissolving. Because the mixture is so hot and cures so fast, the lime gets frozen in these little suspended pockets. It creates the white chunks. So the Romans were intentionally creating a flawed mixture full of unstable chemical pockets. Why would anyone build a wall filled with tiny ticking time bombs of unmixed chemical?
Here is the twist. The bomb is actually a first aid kit. Think about how modern concrete fails. A tiny crack forms, maybe from a truck driving over it or the ground shifting. Rainwater gets into that crack. It rusts the steel reinforcement. The steel expands and the concrete shatters. Game over. But watch what happens when a crack forms in Roman concrete. The crack starts to travel through the wall. Inevitably, the crack runs into one of these lime clasts, the sloppy white chunks. Rainwater follows the crack. It hits the chunk of unmixed quicklime. Suddenly, chemistry happens. The water reactivates the lime. It dissolves it, turning it into a calcium-saturated solution. This liquid flows into the crack, crystallizes, and turns back into stone. It heals itself. Within 2 weeks, the crack is glued shut. The water can no longer enter. The structure is saved. We found pieces of Roman concrete with cracks that had completely healed over. Then we looked at the modern, perfect concrete. It had no white chunks, so when it cracked, it just stayed cracked.
This completely changes how we view engineering. For 100 years, we thought we were smarter than the Romans because our concrete was smoother. We optimized for uniformity. We thought a homogeneous material was a perfect material. We looked at the rough, chunky texture of the Roman walls and saw defect. But the roughness was the feature. The Romans optimized for resilience. They understood that the world is chaotic. The ground will shake, the rain will fall, cracks will happen. Instead of trying to build a wall that never cracks, which is impossible, they built a wall that knows what to do when it cracks. It makes you wonder, where else in our lives are we optimizing for the wrong thing? We try to build perfect systems, perfect schedules, and perfect careers. We try to grind out all the lumps. We try to be smooth. But when the crack comes, and it always comes, the smooth systems shatter. It is the lumpy ones, the ones with the pockets of reserve capacity, the ones that look a little messy on the surface, that last for 2,000 years. The next time you see a flaw, ask yourself, is this a defect, or is it just a feature you don't understand yet?